Welcome, everyone. Today, we are going to explore the principles of workflow automation, specifically focusing on how to identify repetitive tasks and strategically hand them off to AI agents for maximum efficiency. Let's get started. Let's kick things off by defining what we mean by agentic AI. The most distinguishing feature that puts agentic AI in a league of its own is its autonomy. This isn't just about generating text or answering a prompt. We are talking about systems that can make decisions and carry out a set of actions toward a goal without specific instruction at each step. The basics revolve around establishing an observe, plan, act, learn cycle that forms the core of agentic behavior. Why does this matter? Because it gives us adaptability. How we achieve this is by providing the AI with high-level objectives and a set of tools, allowing it to navigate the solution space autonomously. In our deep dive, we realize this shifts our role from step-by-step programmers to strategic orchestrators. Take a look at this flowchart, which illustrates the core agentic loop. It starts on the left when the user defines a high-level goal. The agentic engine takes over and enters a continuous cycle. It observes the environment, plans its actions, acts using external tools, and learns from the outcome to adapt its next steps. This loop continues iteratively until the final goal is achieved, showcasing true autonomy. Now we must learn how to identify which tasks to hand off. This is the strategic allocation of work. The basics are straightforward. Agentic AI demonstrates remarkable effectiveness in tasks that involve systematic processing, continuous monitoring, and rule-based decision-making. Why should we hand these off? Because humans experience fatigue and make errors in high-volume, tedious tasks, while an AI maintains constant vigilance. How do you identify these? Audit your team's day for bottlenecks in data routing or multi-system scheduling. For our deep dive, remember the golden rule of this transition. As AI handles the routine tasks, humans must excel at tackling novel, ambiguous problems that require creativity, empathy, and contextual understanding. This decision tree helps you map out your task allocation. You start with a task audit. If the task is highly systematic and requires continuous monitoring, the path leads you directly to hand it off to agentic AI. If the task is not systematic and heavily relies on empathy, creativity, or ambiguous context, it routes directly to a human worker. This visual helps teams immediately spot workflow inefficiencies. Before we build anything, we need an automation assessment framework. What is this? It's a structured methodology to ensure your AI deployment actually delivers real business value. The basics require us to define the agent's goals and objectives with utmost clarity using the SMART framework. Why? Because vague instructions lead to AI scope creep and failed projects. How do we execute this framework? You must assess the technical, economic, and operational feasibility of building and deploying the agentic system. In our deep dive, we emphasize the data layer. You must identify data sources, define pipelines, and address data quality and security. An agent is only as intelligent as the data and infrastructure supporting it. This mind map lays out the 4 pillars of our assessment framework. At the top left, we have SMART goals to ensure specific, measurable objectives. Top right is feasibility, covering technical and economic limits. Bottom left is data planning, focused on sourcing and security. Bottom right is risk mitigation, establishing fallback protocols and human oversight. You need all 4 branches for a secure deployment. Let's distinguish between traditional and agentic automation. What we are advocating for is a strategic combination of both. The basics are that traditional automation is perfect for predictable data routing, whereas agentic AI provides an intelligence layer. Why shouldn't we just use traditional code? Because standard automation relies on rigid if/then rules. If an unexpected variable hits, the system breaks. How do we fix this? By building layered architectures. In our deep dive, we see the most powerful implementations are hybrid systems. These hybrid systems use traditional automation for routine, role-based tasks while deploying agentic AI for complex decision-making and exception handling. They work together in perfect synergy. This architectural diagram illustrates a hybrid automation pipeline. Incoming data hits the traditional automation layer first. If it's a standard rule match, it seamlessly executes the standard workflow. However, if a complex exception occurs, the system routes it to the green agentic AI intelligence layer. Here, the AI performs reasoning and analysis to determine the optimal action, successfully handling the edge case without breaking the system. To safely orchestrate these workflows, we implement event triggers and hooks. Hooks are user-defined shell commands that execute at specific points in Claude's lifecycle. The basics are that hooks provide deterministic control over the AI's behavior. Why do we need them? Because you cannot leave security or compliance to the probabilistic judgment of an LLM. You need absolute guarantees. How do you implement them? You configure events like pre-tool use to validate parameters before an action is taken. Look at the sample code on the slide. It shows a command hook that runs a linter before a tool executes. In our deep dive, we see hooks act as the bridge between AI autonomy and enterprise safety, serving as unbypassable guardrails. This sequence diagram maps the lifecycle of a pre-tool use hook. The agentic AI requests to execute a tool. But before it touches the target system, the request is intercepted by the hook, which runs a deterministic validation script. If validation fails, the hook blocks the action and sends error feedback so the AI can correct itself. If it succeeds, the hook permits the execution. It is a perfect, automated safety net. As we build these automated workflows, we must differentiate context engineering from prompt engineering. What's the difference? Prompt engineering focuses on designing clear, effective instructions that steer a model's immediate output. Context engineering, by contrast, shapes the broader environment the model operates within. The basics involve giving the agent its goals, tools, constraints, and memory. Why is this critical? Because an agent executing a multi-step workflow over several hours will hallucinate if it doesn't have a persistent operational environment. How do we do this? We use persistent artifacts like a Claude.md file to inject rules at the start of every session. Our deep dive reveals that this relationship is deeply symbiotic. The context builds the world, and the prompt tells the AI how to act inside it. This flowchart illustrates the convergence of our two engineering disciplines. On the left, context engineering sets up the environment, tools, and persistent memory. On the right, prompt engineering defines the immediate task instructions and the AI's role. Both disciplines merge at the bottom into the green node, producing a highly reliable agentic workflow. You absolutely cannot have sustained automation without combining both. Let's examine a real-time, highly impactful use case, customer support triage. Imagine an enterprise help desk overwhelmed by thousands of unpredictable tickets daily. The implementation relies on explicit automation. Instead of a human deciding which department handles a request, we deploy an agentic AI system to categorize and route tickets instantly. The execution is brilliant. The agent continuously evaluates each ticket in context, such as by customer importance, issue urgency, available agent skills, and even the emotional tone of the message. The outcome, unprecedented efficiency. The agent dynamically routes the ticket accordingly. In our deep dive, this highlights the paradigm shift. We aren't writing thousands of if/then rules for every customer mood. The AI interprets the nuance and automates the workflow in real time. Look at the workflow for our customer support triage. An inbound support ticket enters the agentic triage engine. The engine performs an analysis of sentiment and urgency to determine priority. We then hit a decision node. Is the issue routine? If yes, it is autonomously resolved. If no, the AI intelligently routes it to the specialized human staff, equipped with the context summary. Efficiency and empathy, perfectly balanced. We will conclude with governance, maintenance, and next steps. What is governance? It is the ongoing oversight and transparency framework necessary for AI operations. The basics are simple but crucial. Treat every agent as a living system. Give it a feedback loop, a monitoring dashboard, and a way to learn from outcomes. Why? Because unmonitored agents can drift from your business goals. How do we secure them? We enforce transparency so agents disclose their role clearly. We trace every action through logs for accountability, and we ensure agents access only the data they're authorized to use. Our deep dive reminds us that continuous iteration is key. Gather feedback and refine your agents based on real-world operational results. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you. Our final mind map visualizes agent governance. Branching out from the core, we have transparency, ensuring the AI discloses its role. We have accountability, relying on strict action logging and clear human escalation paths. We have security, enforcing data access controls. And finally, continuous iteration, reminding us to monitor outcomes and constantly refine our systems. Master this framework, and your workflows will be unstoppable.